Good morning and welcome back to day 2 of Forward CloudSec 2021. I'm glad everybody is here, awake. Again, as I said yesterday, this show wouldn't happen without our sponsors. They're paying for the space, they're paying for the audio visual, they're paying for our Slack channel. And so we definitely want to make sure to thank all of our sponsors. Flatiron is a healthcare technology company. And their services are focused on accelerating cancer research and improving patient care. Their platform enables cancer researchers and care providers to learn from the experience of every patient. And you can follow them more at Flatiron Health. So first up this morning, we have Noam with Ermetic, and he is going to be talking through Access Undenied, how to figure out what all those error messages are and why. Thank you.
Okay, can everybody hear me all right?
Yep. We hear you.
Okay, great. So, hey everyone. In this section, we'll talk about Access Undenied. As has just been said, it's a tool for automatically explaining AWS access denied errors, which are notoriously opaque. And we made it to solve a problem that's probably familiar to anyone sitting here listening into this. By the way, I'm Noam. I'm a security researcher for Ermetic. We are a cloud security company that's identity first, so I get to do a lot of IAM. So the problem. So this is surely a reasonably familiar scenario. A developer creates a Lambda that needs to access a bucket, and then in the CloudWatch logs or wherever logs are collected, they get this error, client error, an error occurred, access denied. And it's not particularly detailed, and then they furiously slack away to the DevOps, SRE, whoever's in charge of it with, why isn't this working? Please fix this. And everybody has to run around hectically to fix it, but we don't know where that's coming from or where that deny is coming from. Technically speaking, the issue is that AWS errors are mostly opaque, and they can come from really varied sources, right? They can come from the identity policy, from a resource policy in the same account or in a different account, from a service control policy, a permission boundary, a VPC endpoint policy, a session policy, a tag policy. I think that's it. And we need to look at all of these sources and in the dispersed locations where policies are placed in order to find all the relevant ones and give a succinct answer. And to make matters more difficult, error messages are really, really different from one another. So this is just like a very, very partial collection, but we see some of them have only the action name, some of them have nothing and just say access denied, some of them have the principal and the action, some of them even say with an explicit deny or not, some of them have the resource, some have an encoded message that we can then decode that's unique to EC2, but every one is different and they're really differently detailed. And then trying to pursue these error messages and these varied locations in order to find the answer and then reset the permissions, the permissions in a way that works can get really tricky. And under the pressure to restore or facilitate usability, we can end up canceling or forgoing these controls, right? We all know this story. Let's say that same developer's Lambda isn't working. We add a permission to the Lambda execution role. Then we see that that execution role has a boundary. We take something off it. Then we add an explicit allow in the bucket policy. And then we find out that whatever, it was an SCP all along or a condition all along, and we don't really roll back all the changes we made along the way. This both causes permission drift and also causes the don't touch this, this might break type of situation where we're afraid to restructure permissions. So before getting to the rest of the talk, let's perform a few failed calls, see how relatively frustrating and not that detailed access denied messages currently are, and then remember those for the demo at the end. So the first one, I'm using AWS Vault. AWS Vault is just a way to securely get temporary credentials and securely assume roles. And the reason, okay. So So the first thing we're going to do, implicit deny, is just the profile name is try to access a bucket. And I'm like telling you the behind the scenes secret that the reason we won't be able to do that is because of an implicit deny. Right now, okay. Then we'll do another one where we try to access a cross account bucket, and that doesn't really work. Oh, it seems actually that here the AWS Vault config file is broken. It won't matter. We have things prepared for the demo at the end. And one that's denied by an SCP. And the important thing to see is that these messages aren't very detailed and they don't necessarily look different, whether it's coming from an identity policy, a resource policy, or an SCP. Some of them, like this one, are a little more detailed, some are less, but it is at this point impossible to tell why why access isn't allowed. So back to the slides. And the next question that I get introducing the project is, didn't AWS just launch this? So the answer is not exactly. AWS are going to make error messages, or at least some error messages. It seems like it's going to be a rollout, more detailed. Here's the detail we're going to have, according to like what they posted on Twitter. So principal action and resource in predictable places. And then the new thing is a reason and a policy type for the deny. So with an explicit deny, could be maybe an implicit deny. In a service control policy, could be a resource policy, could be something else. Now that's really awesome. A, because consistent and predictable error messages are really great and they make life easier for everybody automating in the cloud. But secondly, because even knowing the type of policy tells you where to look. However, do note it only gives the type of policy causing the error. So there's still work to do after that to find the actual policy missing or explicitly denying. And it only fits like a manual solution, right? Because you have to manually look for the policy negating access. And for security reasons, unless they go with the route of giving encoded messages that are more detailed, this may well be as much as we'll get because giving more information to an unauthorized attacker could be a security risk. So I think they struck a really good balance, like personally, with giving enough detail to make the job easier, but then not too much detail. But yeah, it's not really for scale. Sorry, just a second. Sorry, I have an interruption here. Okay, so. Okay, so now to what we're presenting. Access Undenied is the tool that we're launching. What it does is gives an answer to why access was denied and what steps should be taken to facilitate least privilege access. So we try to give a full, complete, detailed answer to that. The tool does that by scanning the permissions landscape ad hoc, and it supports the things listed here: SCPs, resource policies, permission boundaries, identity policies, conditions, and we are open sourcing it. Should be in the next few weeks as soon as it's really, really ready. So how does it work? We parse the CloudTrail event. We extract the principal action, resource, and condition of the requests. We gather all the relevant policies. We manipulate inputs as needed. And then we use two of AWS IAM's APIs, get context keys for custom policy and simulate custom policy, to receive detailed reasoning for why something did or did not work. And from that, we create actionable output. The reason, by the way, we decided to go with CloudTrail as the input is that it is almost all-encompassing, although quite inconveniently, some actions don't have access denied log, actually. So this is on my personal AWS wish list, to log access denied for all actions. But it's almost all-encompassing, and it's relevant in a lot of the more varied and more difficult scenarios, like a CloudFormation stack being run, or like a Lambda function being run, where you don't necessarily have access to like using client-side monitoring or putting in a proxy server, like or doing one of those things. So I'm going to dive deep into maybe two challenges, depending on how kind time is to me. Which is how to extract the principal action resource conditions and how to manipulate inputs for simulate custom policy. So the first challenge is identifying in IAM language the principle, the action, the resource, and the condition. This has a lot to do with what Ian McKay talked about yesterday in mapping the IAM permission landscape. And I also used a lot of his work on the IAM dataset and the mapping in order to do this mapping. But so the first challenge is that action name and permission name are not necessarily the same, right? List bucket, the permission is called list bucket. The API action is usually list objects v2, and the CloudTrail event is usually list objects. 3 different names for the same thing. We have to know how to do the translation. The second challenge is dependent actions, right? You have pass role, you have tagging, you have these dependency chains, and if you want to know why something failed, you need to monitor, you need to know about all the things, all the permissions that that action is dependent on. Thirdly, extracting the resource and the resource account. Resources are placed in CloudTrail in various places. Sometimes it's in the resources key, sometimes it's in the error message, sometimes it's in the request parameters, sometimes it's nowhere at all. So we have to extract them from varied locations. And all of that is an interesting challenge, and I think something that there's a lot to take away from. Second challenge we encountered is with simulate custom policy. So we decided to use simulate custom policy as the stateless policy engine here because it's universally available, self-contained, and it gives really detailed output. Simulate custom policy isn't how we do things when doing permission evaluation at Ermetic, for example. It is not that quick. It is API speed. It might be throttled at very high request rates, though I'm not sure. And also there are some serious cons to it with regards to odd behaviors. It doesn't support IAM roles as caller ARN, so it can't combine IAM roles with resource policies. It doesn't really support SCPs. It kind of claims to, but then it gives odd answers. So to sum with that, it's a useful tool, but you have to do a lot of input manipulation in order to make full use of it. By the way, I think looking forward, a really interesting community projects for those who want to take it on, maybe me, may not be me, is to work on an open source simulate custom policy that works locally and does things right. I think Eric Sterninger, who presented yesterday over at PMapper, they have a really good, they have maybe the best open source one right now, but it was difficult to use because it's not standalone. It uses their data structures. It works within the context of that project. So a specific problem we had to reduce or translate into simulate custom policies language in order to solve, which is service control policies. So if you don't remember, I'll remind, the service control policy evaluation rule is that to be allowed, an action has to be allowed at every level of the hierarchy, by the root account, by the OUs in the hierarchy above the account, and by the account itself, by the root policy and management account. Now, simulate custom policies handles boundaries really well, but it only lets you use one boundary per call. And again, it doesn't handle SCPs well. So what did we do in the tooling? We took all the attached SCPs at every single hierarchy level, merged all the statements into one policy, checked that policy with simulate custom policy, and then unwound it as needed back into the varied policies to get the target ARNs of the original names. So to simulate one thing, we're running several calls of simulate custom policy in order to use all the different types of boundaries and check them against it. So now on to the moment we have all been waiting for, which is the actual demo of how it works. So you will recall the 3 API calls that we made. The first one was failed because of an implicit deny. It was a list objects call. The second one failed because of an implicit deny in the resource policy and in the identity policy. And the third one had an explicit deny in the service control policy. So if we type in access undenied, we can get like all the options. There's also a CLI mode, so that can come in handy as well. And but in this case, we'll use a file. And this file is just like a record file of the JSON events. You can get it from wherever you store, handle your events. Could be Athena, could be like Elasticsearch, could be whatever you are using to gather these events, because you would want to preemptively filter the ones that you care about. The tool filters out only access denied, but if you want to filter a specific user or specific IPs, that's something that you need to do. Behind the scenes, there is also a config file here that gets you the cross-account roles to handle things that happen in different accounts in the organization. So let's look at the replies. The first reply, so you get the target ARN, the role, the assessment result is identity policy implicit deny. We get the target ARN, which is the role, and the policy we would need to add to it for the request to work. With the second, we had a cross-account implicit deny. So we have cross-account implicit deny. And here, the target ARN of the role with the policy to add, and the target ARN of the bucket with the bucket policy to add. Of course, if it already has an existing bucket policy, user has to be wise and adjust the bucket policy in order for it to work correctly. And the third one, the service control policy explicit deny, it was able to identify the policy ARN of the service control policy and the statement denying. Here it was denied because of a condition on principal ARN, which is the role name of the role. So yeah, works like a charm. Now, with regards to scaling that up, I think there are some really cool possibilities. Not a lot of time to talk about them, but you can, Scott discussed this attaching CloudTrail to Events Bridge and then getting a notification for that for the conditions that you really care about deny. So getting like a Slack notification, an SNS notification. I think any use of this tool which involves scaling it up, one would have to filter either in or out the things that are most interesting, right? So either filter out scanners or routine denials or filter in the things you care about the most. The reason is because access denied is kind of a part of life when writing AWS code. And so your environment is probably littered with a lot of access denied messages. And so you sort of have to filter for the ones that are really notification worthy. Roadmap going forward, so we're going to support more resources with resource policies. We're going to, we would need to hopefully support service-specific permission mechanisms like KMS grant, BTC endpoint policies, maybe going into session policies, although there is a technical difficulty because one would have to go much farther back into CloudTrail to find the assume roll call, multiple replies, and of course, adapting to the new AWS error messages as they roll out. Of course, a lot of acknowledgements are in order here, but I think two big ones is for Ian McKay's IAM dataset and Ben Cahoe's AWS Error Utils. So thanks to both of these projects. It's going to be open source soon, and I would love to see you around, hopefully next time physically at a conference. If there are any questions, thanks.
So yeah, one question from the Slack. So does Access Undenied support CloudTrail logs stored in an S3 bucket and or intelligent troubleshootings? For example, give me the reason my identity last access denied error.
So with regards to reasoning, all of the reasoning is provided here in the result, right? You get the match statement that gave you an explicit deny if it was an explicit deny, or the statement one would need to add if it's an implicit deny. So that's a full answer. The thing I think we sometimes wish we were able to get is near misses. Like this action was almost allowed with the condition, but your EC2 type was this type and not this type that you're allowed to do. However, logically, these are I think, extremely difficult to do because there is no logical definition for a near miss that's salient and consistent. With regards to reading from an S3 bucket, I think it is definitely in the cards to add that in directly. Although I think the way a lot of people work is actually to create that file by filtering the S3. I don't want to build a filtering system for the S3 bucket. So there's likely in most deployments going to be something in the middle between the entire S3 bucket and the logs you're actually working with. But yes, we will do direct access from S3, I believe.
So you mentioned that there are some events that don't have access denied error messages populated. How do you handle that event? And then what are some of the events that you've discovered that you get denied, but there's nothing in CloudTrail for that?
So the simple disappointing answer is when we're running CloudTrail, we don't. If there's no event, then the system just wouldn't know. If there is an event but zero detail, you can run it in a prompt mode. So it would ask you for prompts if you happen to know the missing information, but ultimately it's an information problem. It can't come from nowhere. Example events, let me just check my own notes here, because I don't always remember them. So this isn't documented inconveniently, and I don't have them listed right now, but I'll follow up in the
Of course
Slack.
it's undocumented inconveniently. It's IAM.
Yes, I'll follow up in the Slack chat with a few just so you get it.
All right, awesome, thank you. Any questions from the room? Cool. Well, thank you, and you have a great day.
Thank you. You too, all of you.